My name is Keenan Taylor. I am a scientific illustrator and fantasy author. For Gliding Fauna Week, hosted by Paleo Curiosities, we have a perfect opportunity to discuss the often overlooked but quite successful method of locomotion, and why it's particularly viable in Kaimere, the setting of my literary work and speculative biology project. Gliding is often described as a transition towards flight. While it's true that most flying animals are generally assumed to have evolved from gliders, and this is a useful tool in explaining this complex evolutionary process, I do think it reduces an efficient form of locomotion down to a stepping stone. Transition species as a concept I feel is often overstated in evolution education. A hippo is perfectly good at being a hippo, and not sitting on the sidelines waiting to be a whale. And I think this is the case for a lot of fossil animals we describe as transition species, especially in light of how diverse family trees can be. I can appreciate the concept of transition species as a merit in breaking down complex topics, but I think that gliders should be looked at as they are, and, when you do, a critical advantage over flight becomes apparent: energy efficiency. When flying, animals have to overpower gravity. They must be stronger flyers than the forces pulling them down. The launching muscles of bird legs and the strength in their chest and arms is absolutely ridiculous compared to our own, and they need to dedicate 2 sets of muscles to the task, one for takeoff and one for flight. Pterosaurs got around this issue by making their takeoff and flight muscles both powered by the arms. Many have suggested that this consolidation of takeoff and flight muscles and the efficiency it affords is why many pterosaurs could attain dramatically larger sizes compared to the largest flying birds, which seems perfectly reasonable to me. Gliders don't have to make as many anatomical compromises. They don't have to sacrifice as much for efficiency. Gliders don't require full wings or the muscles to power them, just a patagia, or membrane of skin between limbs and tail, or some other lift-providing structure, like feathers. They don't need the extreme surface area and musculature for powered flight. They just need to be able to fall with style. Gliding was a highly successful strategy during the Tyrant Dynasty of Kaimere, in large part because open forests made up a majority of the terrestrial habitats. Climbers struggled to get from tree to tree, and flyers had to prioritize agility because open space was at a premium. For this reason, gliders thrived during this time. Some gliders, with dinosaurs like Microraptorians and Scansoriopterygids, and nontherian mammals like Eutriconodonts, have gliding descendants on the eastern continent. Many clades, like multituberculate nontherian and adapiform primates, had gliders too. Not all of the gliders in this image reached Kaimere, much less had living descendants, but I wanted to highlight just how strange some real gliders were. Most glide with patagia or stretched skin between front and back limbs, but there was a range of experiments in other configurations. To learn more about prehistoric gliding fauna, be sure to stop by Paleoanalysis on Friday. He's got a fantastic video coming out on 5 of these strange and fascinating prehistoric gliders. Most of the gliders who thrived during the Tyrant Dynasty were hit hard by the dynastic extinction. The large titanosaurs went extinct, and open forests closed up. Now the vegetation was dense from the lack of megafauna, and climbing animals dominated. Arboreal predators like nimmervids could easily pick them off. Gliding wasn't terribly viable at the time, although some survived long enough for the small titans to become giants once more, and the forests reopened. Those who survived long enough for the new Titanosaur dynasty to open up the forests again enjoyed an explosive adaptive radiation. The multituberculates and adapiform primates were the most successful among them. In the known world, indigenous gliders are comparatively rare. Flyers tend to be more adaptable because of the broader range supports stronger genetic diversity, a boon in the hyper-competitive ecosystem that so defines the constant intersection of species from Picardia, Arvel, Nikar, and Earth. There are, however, a few indigenous gliders in the known world. First of these is the volant multituberculates, the flying gophers. The largest is a hypercarnivore common in the boreal forests of the Crescent Highlands and in Picardia. A generalist is found in the Titan Gardens, and the smallest species is found throughout the known world. They are small game specialists, being quite convergent in dentition to Thylacoleo, gripping with incisors and slicing with modified molars. After this initial impact, they will also employ venomous spurs on their feet to facilitate a quick and painless kill. They will also use their powerful incisors to bore into tree trunks to supplement their diet with insects. Competition with small cats is a bit of a problem, but gliding gives flying gophers a significant advantage in the open forest context, and cats are uncommon in their range. Another clade of indigenous gliders is the adapiforms called the flying lemurs by Earth's naturalist. While they can't fly, these primates hitched a ride on the backs of titanosaurs coming to the known world around 12 million years ago. Although most of the descendant species were outcompeted by Earth fauna, mostly because they couldn't endure the ensuing diseases carried by bats and monkeys, two genera have endured to modern times, both with healthy populations. The larger and more common is specialized to Titan Gardens, while the so-called Highland flying lemur is one of the few primates comfortable in cooler temperatures, and has species in mountains, the southern islands, and the temperate rainforests of Picardia. A wide range of predators hunt flying lemurs, notably raptors, flying gophers, and firebirds like the jackalbird. Strangest of these indigenous Chimeran gliders is the ardzu. Adults are conventional basal diapsids that are arboreal and incapable of gliding. Juveniles, however, glide by the most unconventional method, using their massive fanned tails as a sail to be taken by the wind. This is mostly employed for efficient dispersal, as they have no control over where they are taken. Sometimes it does assist in predator avoidance, but this is with mixed results. When dispersing, they can travel several miles with a strong wind at their back before climbing up another tree, and either settling down or launching again based on food availability, threats, or seemingly even personal preference. Clutches of up to 100 are laid by each mother, since their method of dispersal has a very high mortality rate, but those few who survive are part of a community with cosmopolitan distribution, being found on every tropical to temperate continent and thousands of islands. The last glider I'm going to feature is perhaps the surprising entry, the white cockatrice, apex predator of the Crescent Mountains. These 200 to 300 pound eudromaeosaurs are much larger than we usually consider for gliders. They use large wings, a fanned tail, and a patagia connecting the back legs to the tail to slow and control their fall as they descend upon prey below. There are several other gliders in the known world, recent arrivals from Earth, but as I'm pressed for time, I wanted to spotlight the unfamiliar taxa descended from earlier harvests. That's all for today. Next week, we will cover the harvest during the Oligocene that brought us the ancestor of the flying lemurs, along with a whole new cast of strange beasts. Until then, stay fantastic. Cheers, folks!